Hi everyone. My name is Paolo Emilio Silva. I'm a principal engineer at Wētā Digital at Unity for Wētā FX. I've seen a lot of talks like this afternoon about USD structure. So I think it's something that is coming up like more often. So the one thing that I want to do here today is to talk about USD structure. So here we are. Keep in mind the images on the first slides. Those are the only images that you actually see in my slides. So I'm not going to show anything in real time, but it's everything. It's all about USD. So what is the best structure to represent a million cube? I get these questions a lot. You can do all of them, and they're all valid structures. The first one might be very good, like for testing a single point instancer speed, or the last one is probably good, like just for having a sense of how the scene is actually organized. But all the structures are going to produce like the same pixels at the end. So what is actually down to a structure is it very good like for USD, or is it very good for the users? What is that we actually try to get to when we try to build a structure? Some could be more readable, and some could be like better for just the renderer. So one question that we want to bring up and ask ourselves when we actually make the structure is, what is the intent of a USD structure? What are we going to use it for? Are we going to render it? Are we going to pass it down to other clients? Can we have a assumption that different departments within the same companies, or different companies or different vendors can actually agree on adopting one or more structures if they actually agree on the intents? So in a VFX pipeline from zero to finals, there could be one or many structures. One structure could be like the straight line at the bottom. We can call that one the pipeline structure. Basically, like that one is where all of the departments can actually drop in their own published data. Each department could have its own internal structure, which could be adapted from the pipeline structure. And knowing how we can actually map the two, there could be layers on top that will transform the data of the pipeline structure, then readable for other structures that maybe are inside the different departments. Excuse me. Can we actually assume that we have structures that can be non-destructive? Can we take the data in and out of some of the structure? Can we actually access the ins, like the actual bits and pieces of some of the structures in some ways? So we've all asked those questions in various meetings, and it's not about like just describing the USD primitives. It's also like, how do we represent it on disk? Whether we want to share it with some other companies, or whether we want to use it internally in between the different hosts. There are decisions that are constrained by maybe some technical needs. For example, maybe we don't want to have textures within the same allocations of other big files for some networking file system problems maybe. So are those intents like that we actually have to agree with, like the Maya, the Substance, the Solaris, or to say, when you export the data, how do you want to export it? Do we actually assume that we just let them say you can actually access the data in all its parts, and then we actually take care of post-processing the data so we can actually represent it in whatever way we want? I don't have any answers to all of this, but I can give you hints of what we have done at Wētā, what we are actually doing. We'd like to see the intents and the structures from everyone else. We would like to have all conversations going, and we would like to come up together with some sort of like an agreed baseline of what it could be a structure that maybe we can all share together. And maybe one day we can actually write up like some proper guidelines and best practices for everyone to actually be used. So before I get into the details, I just want to go briefly over how do we work. This is a very rough, some slides to tell you how we work at Wētā FX. But so we start from some sort of input from the client. It could be an image, a storyboard, or some sort of like capture on stage videos. We identify the asset, we registered in, we give it a name, we save it in our database. And then we look at the scenes, we look at what the camera looks at, we give a name to the shot, we look at how many assets are in the shot. There is a continuous update in between the shots and the assets. And then we start like looking at the tasks. So this is very important because the tasks are based on the assets, and there could be multiple departments working on different parts of the same asset. So you can see the tasks on the asset side, but there are also tasks based on the shots. So a layout artist can actually build layout based on some specific shots. What happens is that we can have departments that will start cross-working across, like, from a shots point of view, they might need to modify some assets. And so they might start like adding extra representations into the assets because maybe layout want to create a blocking representations for an asset. So in short, like to try to identify what is a shot, we have a lot of representations for a single asset. Those can have different use cases. Each asset can be placed into different element packages. The element packages are basically the layouts of how the assets are placed for specific shots. Different elements packages can actually be used in multiple shots. They can be reused. That could be the concept of master layouts or just very specific layout per shots. And then there are like the different work that artists can start doing, and they might address like individual bits and pieces at different level of this shot. Like what you see here is basically like a shot loaded at lighting time, and the different components that can be updated for different tasks while the shot is going. What happens then is that a lighter working in his shot might want to introduce different edits at different level, which is they might want to lock a specific representation of an asset, or maybe they want to lock a very specific version or some elements and so on. So, having said that, the one thing that we worked on was we need to try to use USD. We adopted USD long time ago, and the very first thing that we said was, can we try to use it to just replace various file formats that we were using for sharing assets with clients? And so we were coming from this thing because a lot of clients use different file formats, and not everyone agreed on even using most of the very old ones that were already out there. And so at some point we said, well, we knew that OpenUSD was not ready for everything that we needed, but it had a lot of features that were probably covering all of the requirements that we had from those file formats. And so we said, let's work with one company and agree on what is a shareable structure that we can use with them. And there we started using USD with one specific client. And we started working with what we call the common asset package, or internally we give it another name, but globally was recognized with a common asset package structure. What is this one? It's a very simple structure. The main intent was to share the highest possible quality of our assets. So what we did was that we said, let's take the highest representations that we have, and let's export it from Maya and make it available as a binary file on disk, as a USD file. And then we have a material file. We have custom render Manuka, and we have custom shaders. So the one thing that we did was to try to flatten down the Manuka shaders into some simple shaders for both USD, preview surface, and pixel surface. And we decided to go with that with our client, so we agreed on this one as well. And both of them were going into just a simple main index USDA file that we were able to just package it up and send it over as to describe an asset. So you can see it's a very simple structure. It doesn't have a lot of composition arcs happening, like maybe just a couple of those happening there. But it was actually working for its intent. It was we need to share just the highest possible quality, and we left everything that was down to the pipeline for the clients to say, if you need to create LODs, you do it in your own way. If you have a renderer that generates LOD on the fly, it's up to you. The only intent for this structure was let's share data with some other clients externally from us. So we were coming from a conversion pipeline, like we have a custom file format internally at Wētā. We have custom plugins for pretty much everything. And we decided to just bake also all of our procedurals into geometry for this structure. But we wanted to do more. We wanted to start using USD internally. So we said, how do we make not just a one-way USD structure where we say we can push it out of the company and someone else will receive it. We want to use it internally. We want to update it. We want to have non-destructive workflows with a USD file. So we want to retain our shaders for the custom renderers. And we actually want to retain the procedurals as they are. And if you were at this morning USD in production course, you have seen I was talking about how to implement the procedurals in USD. So new intent, again, an intent for a non-destructive workflow. So what you're going to see here is probably like the second or third iteration of this workflow. And we're probably going to reviewing again. We are actually reviewing it, and we need to be sure about this one because it's going to be our structure for all the movies that we're going to make moving forward. One thing that I want to just say is for naming clashing problems, all of our hero and proxy representations, I will call them model hero and VAD proxy just for this presentation. So then it's not confusing because proxy was already taken. But they are prepended by the departments that are creating it. There is the model department that creates the hero representation, which is the highest, and the VAD, which is the virtual art department that makes the proxy version, which is very fast for stage. So this one is the new representation. And what you can see is much more complex than the previous one. It has a lot of more composition arcs happening, and this is only one representation. It's the model hero representation. We still start from the geometry, bottom right. You can see the file there. But this one now includes the procedural geometries as actual procedurals in USD. And we bring it up to the actual payload file. So for each representation, we create a payload file that then we actually include in this asset file here. So viewing the asset, you can see a couple of things. When we bring in all of the representation, we introduce them into one primitive that is an abstract prim that we call representations. It's the one at the top. We add all of the representations there under the abstract prim. And then we create two proxy purpose prims called render and proxy. And we use the same purposes that are matching the name. And we add all of the representations as variants on those purpose prims. Now, why all of those variants and all of those representation classes? We have some requirements that we needed to go through, and we are continuously learning about USD. So all of this that I'm talking about is something that we are reviewing, but it worked for the requirements that we had. We want to be able to switch each purpose to any of the representations independently. So we want to have the proxy purpose to be switched to either model hero and not just the simple lightweight component, but also the render purpose to some proxy level quality representation. This is because, like, in dealing with large environments, you don't know exactly how to view a large forest. And if you say, I'm going to load it, unload it, you get bounding boxes. And that's pretty much what you see on the screen. You see a lot of bounding boxes. And when you have like hundreds of millions of instances of trees, then that's the problem. So what is that we can do? What is the first representation that we can actually use? We could say that we can use imposters is our lowest representations for an asset. It's very good for a far distance. You can see a forest, kinda. But when you start getting closer, then you don't actually see the assets. You see those sort of like cards, camera facing. And so this structure allows us to also have per element settings that we can do, and we can control individual element representations, and we can actually switch a red carpet area to a much higher resolution. and maybe some of the hero elements to like the highest level of the resolution that we had, and maybe use instanced leaves instead of just kites and non-instanced leaves in some of the trees. And this is for the fast preview in what you see here is actually Houdini GL in Solaris. Excuse me. So we then add, as I said, all of the variants under a abstract class prim called representations, and that's because you don't have to then switch the proxy and render prim to a specific variant to see its content. Lighters might want to update, for example, the model hero, and they want to see what is the content of the model hero, but they don't have to switch to model hero to see which prims they might need to address for a specific edit. Just remember, we don't have just two representations. You've seen previously, we could have much more representations than just model hero or VAD proxy. We could have the same variant loaded in both purposes. I can load model hero in render purpose and in the proxy purpose, but I actually would like to have different opinions on them. So what I can do is that I can switch the render purpose prim and the proxy purpose prim to model hero, and then I can say, well, I want to see in Karma a blue couch, and I want to see in Houdini GL a red couch, and just because I need to do something with it. The users have the ability to apply different opinions on the same representations, but on a per-purpose basis. They can also go on the representations class, as I said before, and just apply edits to a model hero that will automatically apply to both purposes because it is actually inheriting from the representations class there. So all of this might actually come with a cost, and you say, like, what is the actual cost for having all of those extra prims? First of all, we don't know exactly yet. Like, we did some tests, we didn't notice a lot of that being an actual problem, but we keep an eye on it. As I said, like, this is quite important for us as being a non-destructive workflow intent. But the one thing that we find very useful is, for example, in Solaris and so in other hosts, you can actually disable abstract prims in the outliner. And mainly the outliner is going to be affected by this because abstract prims are not, usually you don't traverse them, usually you don't send them to Hydra. So the actual cost comes from just an outliner standpoint. One thing that we were wondering was, if an artist has to do an edit, they can go into the model hero, they can see the full representation of the data there. Does it always have to be there? Can we, on demand, expand the content of model hero when it's actually required? How much is going to cost apply an edit that actually adds extra, like all the content of those representations when they actually are needed versus they're always there? If we don't find any problem in having them always there, then maybe we just keep them there, and we'll see how that goes. What about the layout structure? Because those were just the assets. For the layout, we basically create like, we call asset elements what is actually all of the individual elements. When you take a chair as an asset and you put it into a layout, that chair becomes, it's given a unique name. So if you put two of them, it's called chair 1 and chair 2, for example. And they are actually elements that are inheriting from the actual chair asset. And so in this case, we put all of our asset elements under a root workspace prim. It's important because USD doesn't have a concept in the stage of a root prim. You cannot transform it. You cannot apply prim vars on it. So we needed a root prim that we can consider this is the content of all of our data in the actual layout. We then take all of the assets that are used in the layout, and we basically put them under a class prim. So that class prim will be the library of all the assets that we use in the layout. And all of the elements are actually inheriting, as you can see at the bottom in green, inheriting from those classes. The actual content, it's not loaded on the element side, it's actually loaded within the libraries, like the assets themselves bring in the payloads. We actually do like global edits through those classes, and the one thing that we do heavily is also use instancers. And so we make sure that every single things that can actually use an asset, whether it's a point instancer or an element, can have its edits done from the classes. And since we have very large environments, we use native instancing or SyncGraph instancing quite a lot. And so we have a global class for editing that drives the instantiable metadata of all of the elements, whether they are prototypes or actual elements in the scene. And it actually enables or disables the instantiable flag. And that allows artists to say, I do want to de-instance this element specifically for whatever reason. They can just switch a variant on the instantiable class. So to recap how we actually use this, artists can go on the purpose prims and apply the edit on a specific purpose for a specific element in the layout. Or they can apply an edit to the representation that will be used for all the purposes of that specific element. Or they can go on the asset class library and they can apply an edit for all the proxies of all of the elements that are inheriting from the same asset. Or they can just globally say every single model hero in whichever purpose it's actually used will be affected by those edits. Excuse me. So we were coming from this, and the one thing that we are now investigating is how do we work with the other departments? What can we actually do? Can they use the same structure? Do we need to review some of these concepts for the other department? Well, we are currently investigating. So this year is the year of the investigation across all of the departments at Wētā. And the one thing that we want to do is that we need to rethink about we're actually publishing the USD. So we did a presentation about a contribution stack at the USD BOF, and we want to have USD be more like a core part of our pipeline, replacing our existing scene management system. We're going to enable more sparse edits. There will be much more layers and much more composition arcs happening in the structure. So it will be different probably in a couple of months. And how can we have USD more like a first-class citizen? We don't want to have a Wētā USD version. We definitely want to use out-of-the-box solutions. And we're definitely more than keen to contribute, like, as much as we can. We're not strictly locked in one DCC. There are definitely DCCs that are more advanced in terms of USD adoption, but we know it's just a matter of time. So we want to work with everyone to ensure that we come up with a baseline approach that works for all of us, and it could be just a starting point of whoever is approaching then USD and asks for what is the structure that I should use here. Thank you.